Deep in space, something strange is stirring. Imagine two colossal black holes colliding, sending ripples across the very fabric of space-time. But hidden within that cosmic hum lies a mystery, one that could rewrite everything we know about black hole mergers. Could this signal be evidence of something far more tangled and thrilling than anyone ever imagined? Scientists may have just picked up something extraordinary. A third black hole lurking in a collision. Yes, when two black holes smash together, they produce a kind of background hum. But in one remarkable 2019 event, researchers noticed something unusual within that hum. It appeared as if a pair of black holes was accelerating in a way that shouldn't have been possible, unless a third hidden black hole was involved, hovering nearby and tugging at the system. If you're fascinated by cosmic mysteries, make sure to hit that like button. It really helps keep these discoveries coming. This could be the first clear proof of a third compact object inside a black hole merger. Let's break it down. When two black holes are locked in a close orbit around each other, scientists call them binary black holes. Just like regular black holes, these systems come in two main types. Stellar mass binaries, formed when massive stars end their lives in pairs, or when two separate black holes capture each other. Supermassive binaries, thought to form when two galaxies collide, and their central black holes eventually begin orbiting one another. Some scientists jokingly call the first type vanilla and the second chocolate, but really the universe doesn't come with a flavor guide. Have you ever wondered what happens when two black holes of very different sizes meet? Could the universe be hiding even stranger secrets right inside these collisions? Drop your thoughts in the comments now. I'd love to hear your theories. The first direct proof of stellar mass binary black holes came in 2015, when LIGO detected gravitational waves from a massive collision. Not only did it confirm that binary black holes exist, but that they merge spectacularly. If you're enjoying this deep dive into the universe's secrets, consider subscribing and hitting the bell icon so you don't miss the next cosmic revelation. Supermassive black hole pairs are trickier. Evidence remains mostly indirect. Astronomers have spotted galaxies that appear to have two cores, potentially each hosting a black hole. Others look like they might have two black holes hiding inside a single core. Some galactic centers even flash with periodic bursts of light, hinting that a giant object might be orbiting a black hole there. Odd motion in certain galaxies suggests binary supermassive black holes. For example, one galaxy has a black hole moving in a strange way. It could mean it's part of a merger or a binary system. And there's a quasar that appears to have a pair of black holes orbiting each other every 1900 days. When two galaxies collide, their central black holes don't usually crash immediately. They often fly past each other on wide curves unless something slows them down. That something is called dynamical friction. Basically, when a black hole passes near stars, it gives them a slingshot boost, losing some of its own speed in the process. With repeated encounters, the black hole's slow enough to get stuck in orbit, forming a binary system. At first, this works well, but as the black holes get closer, they start clearing out the stars and gas in their path. With less material to slow them further, they eventually stall. Only when they get very close does mutual gravitational attraction make them spiral together. So, the big question is, how do they make that last jump? More stars or gas might drift close enough to steal energy each time they swing by. Another possibility is dark matter, an invisible and hypothetical form of matter. And then, there's a dramatic option. What if a third supermassive black hole joins the mix? This can happen if the galaxy with the pair collides with yet another galaxy. Three black holes together create chaotic orbits, opening extra pathways for energy loss. They wander through more of the galaxy, interacting with more matter, or their orbits stretch into long ovals, losing energy through gravitational waves. Let's check the life of a binary black hole in detail. In spiral, two black holes slowly orbit each other, shrinking their orbit bit by bit. As they get closer, they spin faster, making gravitational waves stronger. Innermost stable circular orbit, ISCO. the last safe orbit before they spiral in for good. Merger. Orbit becomes unstable, black holes plunge together, gravitational waves peak. This is the loudest and most dramatic phase. Ringdown. After merger, the new black hole shakes off distortions, settling into a smooth, stable form. The gravitational waves fade like a struck bell. Since 2015, scientists have logged about 300 black hole collisions thanks to gravitational waves. Studying these ripples reveals black hole sizes, and sometimes hints at hierarchical mergers, where black holes merge step by step to form bigger ones. Black holes born from stars have size limits. If a star isn't massive enough, it collapses into a black hole after a supernova. Too massive, it blows apart entirely, leaving no black hole. So, spotting a black hole heavier than a certain limit likely means it formed from earlier mergers, not directly from a star. Back to our 2019 event, the masses were unusual. One black hole was just 2.6 solar masses, tiny, almost a neutron star. The other was 23 solar masses, a huge mismatch. A team from the Chinese Academy of Sciences suggested this pair might be part of a more complex system, with a third, much larger black hole pulling on them. They studied gravitational wave data. If a binary is circling a third black hole, the signal should show extra acceleration along our line of sight. The model fit the data perfectly. Acceleration of about 0.0015 times the speed of light with 90% confidence. This is a very strong hint that a third hidden black hole was indeed there. If true, this means black hole mergers aren't always simple two-and-done events. Sometimes they happen in messier, more complex setups, and other strange cases might be hidden in the data, waiting for the right tools to spot them. So, if this cosmic mystery pacified your curiosity, smash that like button, drop a comment with your thoughts, subscribe, and don't forget to ring the bell for more mind-bending space discoveries. Stay tuned, because the universe always has more secrets waiting. And who knows what the next black hole collision will reveal.